What is ultimate tensile strength, UTS, in material tests? Imagine pulling on a rubber band or a metal wire and wondering how much force it can handle before snapping. That's where understanding the maximum stress a material can endure comes into play. Today, we're exploring what ultimate tensile strength really means in material testing and how it fits into failure analysis and design processes. When engineers test materials, they use a machine called a tensile testing machine. They take a small sample, often shaped like a dog bone, and slowly pull on it. As they do this, the material stretches and deforms. At first, it stretches elastically, meaning it can go back to its original shape if the force is released. But as the force increases, the material begins to deform permanently. This is called plastic deformation. The ultimate tensile strength is the highest point on the stress versus strain curve during this test. It's the maximum stress the material can handle before it fractures or breaks apart. To find this, the maximum force applied is divided by the original cross-sectional area of the sample. The result is expressed in units like megapascals or pounds per square inch. Knowing the ultimate tensile strength helps in many ways. For example, in failure analysis, if a part breaks at a stress lower than its UTS, it suggests other factors like flaws or improper use played a role. It's a key indicator of how strong a material truly is under tension. Designing material tests involves setting specific parameters, such as the size of the specimen, the rate of pulling, and the testing standards. For metals, standards like ASTM E8 or E8M specify how to conduct these tests to get consistent results. For plastics, ASTM D638 is used. These standards ensure that the UTS measurements are reliable and comparable across different tests and industries. In real-world applications, knowing the UTS is vital. Structural steel used in buildings must withstand tension forces without failing. Aluminum alloys in airplanes need to handle flight stresses safely. Polymers in cars and electronics are tested to ensure they won't break under mechanical stress. Composite materials like carbon fiber are tested to balance strength with weight, especially in sports equipment and aircraft parts. Failure analysis often relies on UTS data to determine if a material's strength was exceeded or if other issues caused the breakdown. Analytical and simulation tools help predict how materials will behave under different loads, making the testing process more efficient. In essence, ultimate tensile strength is a fundamental measurement that tells us how much load a material can take before it fails. It's a cornerstone in designing safer, more reliable products and understanding why failures happen.